15 to 30 kilometers from the Earth's surface, a gas called ozone surrounds the planet. The ozone acts as a barrier between Earth and the ultraviolet radiation from the Sun. However, pollution has caused the ozone layer to thin, exposing lives on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The main cause of the normal unknown is the greenhouse effect. Gases in the atmosphere, such as water vapor, carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons, let the sun's heat in, but keep some of the heat from escaping, like glass wells of the greenhouse. The more greenhouse gases in the atmosphere, the more heat gets trapped. Human activities like the burning of fossil fuels have increased the amount of carbon dioxide in the atmosphere by more than a third in their industrial revolution. Cs are mostly found in refrigerants, aerosols, and plastic products. These man-made chemicals get caught in the winds of the equator and directed to the south by the force of polar vortex in the southern hemisphere. Chemicals like chlorofluorocarbons or CFCs are the major culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. When CFCs are exposed to ultraviolet rays in the atmosphere, it breaks down into substances that include chlorine. The chlorine reacts with the oxygen atoms in the ozone and rips apart the ozone molecule. The simulation by NASA shows carbon dioxide levels of every day in early 2000. The major sources of emission of ozone-depleting substances were from North America, Europe, and East Asia. America's coal plants are mostly in the Midwest and Northeast. In 2007, the South Asian countries like China passed the US as the world's biggest carbon dioxide emitter. Nearly 70% of China's energy comes from coal. Greenhouse gases are a global problem because wind spread them far beyond their source. Due to this, the countries most vulnerable to climate change are often some of the lowest emitters of carbon dioxide. The rapid increase in the greenhouse gases in the atmosphere has warmed the planet in an alarming rate. While Earth's climate has fluctuated in the past, atmospheric carbon dioxide hasn't reached today's level in hundreds and thousands of years. Climate change has consequences for our oceans, our weather, our food sources, and our health. Ice sheets such as Greenland and Antarctica are melting. The extra water that was once held in the glaciers caused sea levels to rise and sends out ocean flooding coastal regions. The warmer temperature also makes weather more extreme. This means not only more intense major storms, floods, and heavy snowfall, but also longer and more frequent droughts. These changes in weather pose huge challenges. Growing crops have become difficult. The areas where plants and animals can live are shift and water supplies are diminished. In addition to creating new agricultural challenges, climate change can directly affect people's physical health. In urban areas, the warmer atmosphere creates an environment that traps the increased amount of smoke. This is because smoke contains ozone particles which increase rapidly at higher temperature. Exposure to higher level of smoke can cause health problems such as asthma, heart disease, and lung cancer. From heat waves to hurricanes, from droughts to floods, extreme weather events are becoming more frequent, putting lives at risk. In order to prevent further dangerous levels of climate change, countries around the world signed up to the Paris Agreement. The Paris Agreement aims to keep global warming below 2 degrees. To stop the planet getting warmer, we need to reduce the use of fossil fuels and increase the share of renewable energy like wind and low carbon sources. Ozone layer damage is more like a thin patch with the thinnest areas near the poles. The ozone layers above the Antarctica in particular has been impacted by pollution since mid-1980s. There, the region's low temperature speeds up the conversion of chlorofluorocarbons to ozone-damaging chlorine. While the scientists estimate that the chlorine levels would return to natural state in about 50 years, thanks to the protocol. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Also, thanks to the pandemic lockdown, which supported the reduction in emission of carbon dioxide and other ozone-depleting substances. This year, the ozone hole over Antarctica was far smaller than expected. In fact, it was the smallest since the ozone hole was discovered. Although CFCs were banned by the Montreal Protocol in 1987, they last a long time in the atmosphere. Ozone depletion is enhanced when temperature are colder. So the ozone hole fluctuates with the season, appearing the colder in austral winter months and disappearing by summer. It reaches an annual maximum size in early southern spring, usually in October. This year, the polar vortex, a spirally wind pattern over the South Pole, was unusually wonky. This warmed the stratosphere, the part of the atmosphere where the ozone layer significantly slowed down ozone depletion. Although small ozone hole in 2019 was caused by weather pattern, the ozone layer has shown overall sign of improvement as a result of Montreal Protocol. NASA and NOAA have worked together to study the ozone hole since their discovery.